The Cranky Geek Fall 2021 show is possible thanks to our sponsors, Google, Agora, Daily, Dolby.io, Element, Intel, and Ring Central. See the links in the description for more information.
Our next speaker has been involved with WebRTC since the early days. I'm glad to have him here as part of Cranky, speaking at the first time. So Matthew Hodgson, he started an open source distributed and federated communication system that was a really good match for WebRTC signaling. And today that project's incorporated under a company called Element. But Matthew will be talking about his research and extending their distributed open source system for SFU platforms. So it's all yours, Matthew.
Brilliant. Thanks very much. And yep, I'm very glad to be here. I think I was actually at the first ever Cranky Geek in person back in the day, so technically my second appearance at the event. So I'm here to talk about Matrix. Matrix is an open source project, as you say, and it's a decentralized communication protocol and public network. It's actually looked after by the nonprofit Matrix.org Foundation, although my day job is Element going and providing commercial solutions on top of Matrix too. So Matrix itself is, as I say, an open network for secure decentralized real-time comms. You can use it for interoperable chat. You can use it for VoIP signaling, as we just said. You could use it as a signaling layer or a world layer for VR and AR. You can use it as an IoT data fabric for any kind of real-time information. The idea is basically you can publish and subscribe to replicated, distributed real-time data of any kind. We've got about 41 million people on the public network today, about 80,000 deployments. We've been at it for about 7 years, and the intention is really to just provide the missing communication layer of the open web. So architecturally, very, very simple view here. Shows 3 blue Matrix home servers out on the public network, and each server has 1 or more clients attached to it. So it looks a little bit like email or SIP or XMPP or some other federated communication protocol. But the catch is that the messages and the events sent by these clients get replicated over all of the servers going and participating in a given conversation. So there is no single point of control, and there is no single point of failure on any communication that goes and happens over Matrix. Now, the ecosystem as a whole is pretty big these days. You have the Matrix specification that defines all the HTTP APIs in a standard manner, which can be used by clients at the top to talk to servers at the bottom. We provide Python, Go implementations of the server. The purple stuff is stuff from the community. There are servers in Rust, C++, Elixir, many others. And on the client side, we provide stacks on JavaScript, iOS, and Android. Everything is Apache licensed so that you can use it to build your own decentralized end-to-end encrypted real-time communication stuff. Worth mentioning is our next generation clients. One is Hydrogen, which is an incredibly lightweight and progressive web app Matrix client. And another is Matrix Rust SDK, which we're starting to adopt for all of our native clients going forwards. And then the community has hundreds of other Matrix clients out there, including perhaps ones which you could build yourself. So WebRTC signaling in Matrix today is pretty mature. We've had it for 6 years. And in fact, my colleague Dave Baker spoke about it at the last Cranky Geek, where we explained that you can go and set up one-on-one VoIP calls by passing SDP offers and answers and trickle ice between 2 different clients, which could be sitting on different servers. So here we have Alice on alice.com talking to Bob on bob.com, and you would have a mix of Alice sending SDP offer and an invite, trickling through some ice candidates. Bob responds with an answer, sends some candidates too. Alice then selects the answer from the device which is actually going to talk to, in case Bob has multiple devices. And then SRTP flows, perhaps overturn via WebRTC as normal. So it should be pretty familiar to anybody who has done SIP-style signaling over Matrix for WebRTC, except we have our own sort of Matrix dialect of it here. Now, group call signaling in Matrix has been a completely different situation over the years. Originally, we went and specified that every room had a single predefined MCU, so multi-point conferencing unit, i.e. conferencing server focus, typically implemented by FreeSwitch, but we also hooked up Asterisk. which participants in that room would call over one-to-one via a bridge if they wanted to jump on a conference together. So you can see architecturally, the server had a bridge via Verto over to FreeSwitch. Everybody would jump on this. It's centralized, it's MCU, so it's old style mosaic conferencing together. And what we did was actually to switch it out for Jitsi. So we then switched to basically storing a Jitsi URL in a room as what we call a widget, which is an embedded application that clients can use in order to coordinate on anything. And it could be an embedded Grafana dashboard or an embedded Jitsi widget or whatever it might happen to be. This is certainly an improvement in that you get all of the SFU UX capability of Jitsi, but still it's centralized, and you can see these three clients might be talking through to a single Jitsi meet. And also we've got quite a lot of moving parts here. And in fact, the problems that we had is that unlike the rest of Matrix, we are centralized on that single Jitsi provider. And if it goes down, it's going to kill it for everybody on that call. You've got a lot of moving parts here. Jitsi doesn't use Matrix for WebRTC signaling, so you have to maintain a whole separate XMPP stack for its own signaling using Prosody. You have the problem that it doesn't map through to Matrix's access control. We're very proud of Matrix having decentralized access control, so you can plug together servers from completely different parties and still maintain who is allowed into a conversation and who's been kicked from a conversation and all that sort of thing without any central authority to dictate it. And so we had to sellotape that together with Prosody via Lua. It doesn't interoperate with Matrix one-to-one calls, which just feels strange and weird. And it doesn't leverage any of the verification or identity that we have in Matrix for things like QR codes in order to check that people are talking to the right people. So we wondered, why hasn't anybody ever defined as an open standard for group call signaling before? And what would it look like if we took the one-to-one signaling in Matrix and extended it to work with groups? So what we've done is to go and define a standard open signaling layer to let clients and what we're calling foci, so these are conferencing servers, could be SFUs, it could be MCUs, it could be some other exotic type of conferencing server. We don't care. They're run by different people, and we plug it into a decentralized call fabric, and we don't mandate any given architecture. So if you've got a big chat room with lots of people in it, and there are SFUs available to clients in that call, you can use them. And if there are MCUs available, you can use them too. And if you don't have any servers, you can always go full mesh. So it's really up to clients to pick the foci, the SFUs or the MCUs to use. Either one's given by the server, or they can use other ones advertised by users in that room. And in practice, these foci are just existing SFU or MCU implementations which are hooked up as Matrix endpoints. So it basically gives us decentralized, cascaded SFU MCUs. Now, what I'm going to talk about here has been specified in Matrix as Matrix Spec Change Proposal MSC 3401. So if you're into that sort of thing, please Google it and check it out. So architecturally, what we have then is that each Matrix server optionally has one or more foci associated with it. And these foci go and trunk the calls together. So you have a genuinely decentralized cascaded conference. So here, each client, say, is in the same call at the same time. These three in the bottom left are going and talking to the SFU associated with that deployment, which might be in, I don't know, matrix.org. This one on the right might be mozilla.org. This one at the top might be fosdem.org. And people are locally conferenced together, whilst then also trunked together. So if you're familiar with how Octo works for Jitsi, for cascaded conferencing, it's a similar approach, except the nodes are run by different people and can be different implementations. So signaling-wise, what happens is that Alice on alice.com sends a call event into the room. Then she sends a membership event to say that she's going to join that call. Then Bob might also say he's going to join that call. And then in a full mesh approach, at least, Alice and Bob just set up a normal one-to-one call between each other. Likewise, Charlie on charlie.com might then choose to join that call, sends her the membership event, sets up a call through to Alice, sets up a call to Bob, and hey presto, you've negotiated a three-party full mesh over this decentralized network. So just to recap, the initiator is creating an m.call state event to announce the existence of the call. It says, is it voice or video? Should it ring the people? Should it prompt them to join? Should they auto-join like you get on Discord? And it has a human label for the instance. It also says what focus, if any, is being used for people who don't have their own conferencing servers. And then the participants join the call as member events. It says what foci they are using. It advertises the media stream and track and capabilities that they are sending, and also whether they're a composite in an MCU world. Then, actually adding foci into the full mesh mix, we've been looking at both Ion SFU, which is the Golang SFU built on the Pi and WebRTC stack, adding a matrix signaling transport in via Go Matrix, one of the matrix SDKs in Golang. We've also looked at Media Soup using the JavaScript node bindings for matrix, encouraged by Mozilla Hub's success in this domain. And Robert Long, who's working on the actual implementation of this, joined us from the Mozilla Hub's team and has had a lot of experience and success doing that. Right now, we're selecting which implementation to use for our own elements that we pitch at our own SFUs, which we use at Element. But obviously, people can use their own or use the standard to hook up their own SFUs. We haven't done any MCUs yet, but it's probably a matter of time. And participants decide which focus to use. If their server has provisioned them with a given one, you call that. If not, you call the nearest one based on latency from other people's advertised membership events. Otherwise, you just start calling people for mesh. The way you call it, a plain matrix one-to-one calls. So the foci have matrix addresses like SFU on NYC or at london.matrix.org. And the only interesting thing is that the calls have lots of inbound streams. Could be a simulcast, could be a poor man simulcast, to be decided. You then control the focus over data channel, selecting which streams you want to subscribe to, and then the selective forwarding unit selectively forwards the appropriate stream to you. On the matrix side, they act as application services, sniffing the room to see which other foci exist and calling them. And this is currently full mesh between the foci. End-to-end encryption will be there via insertable streams or encoded transforms, as we should call them, and S-frame. Finally, we've changed the signaling transport. So rather than putting all of the signaling events as JSON blobs into a chat room, you can also, you instead go and send them to device between devices rather than wasting people's bandwidth with other people's signaling. But the WebRTC actual semantics stays the same. We also get proper perfect forward secrecy end-to-end encryption using ON. So lessons learned so far with this, we've got a test client implemented and up at matrixvoid.dev that I'll show very briefly in a minute. So far it's only for mesh, but it's working really well in all browsers, including mobile Safari. We've had a lot of fun with Safari, especially what happens when you can't call get user media multiple times. And you have to clone the media streams and replace the media tracks to stop them dying on you. Also, lots of fun with CSS performance. Turns out that animating width and height drops your frame rate on mobile Safari to about 2 frames a second. Also fun with glare problems and nice candidate gathering, but those are all sorted now, and the demo is actually working really nicely, and we're looking to build it into a proper product ASAP. Next up, we'll be adding in SFUs and then using this in VR and AR environments, as well as plain old voice and video conferencing. So with all that in mind, let me very quickly, hopefully show you what this looks like. So here we have one running on matrixvoid.dev, and I'm jumping into a matrix room, which has just got me in it now. What I'll do is to take my iPhone here and go to a different deployment. This one is on robertlong.dev. I'm just sitting here in normal mobile Safari, and I mute myself. And you can see that you've got a nice mobile Safari to Chrome thing. Now on my other laptop down here, I can log in again on robertlong.dev. So this is again federated across 2 different servers here. And we've gone and negotiated a nice full mesh. We can do things like move folks around. We could change the layout to be based on active speaker. We could go and set a screen share going, and the screen share is even coming up here on mobile Safari too. So this is what it's looking like right now. Can't wait to add in SFUs, and hopefully this will be the future of group calling on Matrix and anybody else who wants to use it.
Cranky Geeks Fall 2021 WebRTC event is possible thanks to our sponsors. Element used the Matrix Open Protocol to support real-time collaboration. Google and WebRTC.org supporting web real-time communications. Agora, the real-time engagement platform. Daily, build communications into any application. Dolby.io, the API of sight and sound. Intel, offering a scalable open-source media server. And Ring Central, revolutionize your communications with the Ring Central APIs.